Hey guys, and welcome to the third episode of Refactoring Explored. Today we're going to talk about the refactoring lifecycle, or the cycle of refactoring in practice. So let's get started. Basically, what is the refactoring cycle? Well, it's a cycle or a recipe that gives you a sense of control, a sense of direction and context of what you're doing. It's basically a step-by-step recipe that could be followed, and it's pretty much like a template of steps. So you would know exactly, if you follow that, you know exactly what you're doing right now, what you've done already, and what you need to do, how you prepare for it. So it gives you a control, a sense of control. It gives you a sense of, I know exactly what I'm doing, and I know exactly how I'm going to do it, and how I'm going to approach a specific problem or a specific step right now, how I'm going to design this test, why I need to design this test, and so on and so forth. Now, basically, that's okay, but how does this cycle look like? And if I wanted to graphically represent this, how would I do that? Basically, this is how the cycle look like. Now, you need to start reading it from the top center, and the quads are going to go clock cycle, clockwise, So I would go with smell detection smell detection and diagnosis. Then the client identification. Then you go build your safety net, and you refactor the smell, and then you clean up after yourself. So what is that? Let's talk about each and every one of those. Well, for the smell identification and diagnosis, come on, it makes sense. You must first realize that there was something wrong with your code, and you need to identify exactly what it is. You need to first recognize the existing code smell in order for you to understand how to treat that code smell. You need to know exactly what it's called, what it causes, and how it was how it came to be, in order for you to know exactly what you need to do to get rid of it. So it's pretty much like in medicine. You need to understand the diagnosis of a disease. I need to recognize there's something wrong with me, and then, or there's something wrong with my patient, and then I need to run some tests, or I need to know exactly how to diagnose and pinpoint the exact disease that my patient has, to run the diagnostics, basically. And this is the exact step here. I need to identify the smell that is happening throughout my code. The second thing is that after you have identified the smell, you need to change that smell. Now, that smell is basically a problem with some API, right? But here's the thing. This API is probably being consumed by some other client. It's a server to some client. And maybe if I break something with this API, maybe that client is not going to be so happy about it, right? So I need to exactly identify which clients consume the Smelly API. I need to know exactly where those are. This is going to be very important at the beginning of this stage, because later on I need to understand how I can make sure that my refactorings did not break the client code. How do I do that? Well, by testing, of course. And in order for me to test the client or the clients that consume my API, I need to know their business or the domain logic of those clients. I need to know exactly what acceptance criteria or how those clients work and how they depend on my API. So when I change the API, I know exactly how to practice those. And how do I do that? Well, it's very simple. I need you to cover the client code with safety tests. If the clients are not already test covered by some developer who wrote them, you're going to need to start covering them with those tests. And what this does basically is that it practices the business logic or the domain of those clients, and it makes sure those clients are not broken, or it makes sure that when they're broken, you would be the first one to know, and so you'd know exactly where it is and pinpoint the exact location, because fault localization is one of the very key, the most essential key components of unit tests. So you write some unit tests that'll practice the client, and you'd make sure that, yeah, I understand how that client now works, and I know exactly what it is. And if it fails, if the test fails, it's objective, right? So I know exactly why the client is failing, because something is wrong with the API it's consuming. So now I know exactly what I need to do. And then you would be able to perform refactoring, right? So after you perform the refactoring, you need to be able to identify if that refactoring was done correctly, or it basically blew something up in the clients. And how do you know that? Well, you run the tests before and after each change you perform. After safely making sure you know exactly, if fewer changes break the code or break the clients, you would start performing your refactoring according to what? According to the potential smell that you have. Let's say I have some kind of a long method and I decided to start using extracting methods, okay? And the extracting methods, after every time I extract a method, I'm going to run the tests and make sure that the client is not being broken. So that's basically what it is. Now, after you're done and you have performed all those refactorings, you need to clean up after yourself. But what does that mean? Well, sometimes when you're, for example, building some kind of a delegation methodology or a delegation technique that delegates some system calls, or not system calls, I'm sorry, like not the system calls to the operating system, the system calls to the class, like your system basically is making calls to your class, to your Smelly code now, which is not Smelly anymore. And you're basically extracting those pieces of functionality and you're putting them in another class, and you're making the first one, the original, delegate to those or to that new class. Now let's say this delegation is no longer going to be required and you're going to make the clients talk to the new class directly. Then maybe I don't need that old class anymore, so I'm going to get rid of it, right? Maybe if I commented out some piece of code that is now dispensable because, come on, it's commented, the compiler or the interpreter doesn't execute that anymore, then go ahead and totally remove it. And there you have it, a complete life step-by-step cycle that you could follow dependently in order for you to do it right. And why do I need a step-by-step process to do it right? Because it always keeps you safe. It always gives you a sense of control. It always gives you a sense of purpose. You know exactly where you were, where you're going, why you're doing what you're doing, so you'd feel absolutely in control. And there you have it. So thank you very much for watching this episode. If you like this episode, please smack that like button. Subscribe to the channel if you're not yet subscribed. And please do share this video because I need to hype this series as much as possible so you'd find better content on my channel in the future. And I'll see you on the next one.